Hello, everyone. I'm Harry Raduege, and I'm with the National Cybersecurity Center, which is located in Colorado Springs. And we pride ourselves there at the National Cybersecurity Center on focusing on the fourth and fifth operational domains, those being space and cyberspace. And we started with the cybersecurity focus when we opened our doors at the NCC in 2018. And that was largely due to the drive and determination of then Governor Hickenlooper, now U.S. Senator Hickenlooper, who is still very much involved with our National Cybersecurity Center. Then a year later, in 2019, we were asked by the newly formed Space ISAC, or Information Sharing Analysis Center, to take on an executive, operational, and administrative role. The Space ISAC is a 501c6 membership-driven organization, and they needed someone to actually run and operate the Space ISAC operational mission. And so we have that mission. And so what makes it unique with the NCC is that we have a cybersecurity domain and we have a space domain, and we're finding more and more the importance of the intersection of those two very important areas. So we've been concentrating on establishing and normalizing cybersecurity and space offerings at the NCC, and now there are other major considerations like artificial intelligence that are becoming a huge factor in almost all things space and cyber. So today we want to delve with this panel into the intersection points among space, cyber, and artificial intelligence. So in doing so, we're fortunate to have captured, and I say captured because these two gentlemen are very much in demand, running around and running businesses and organizations and big thoughts. But we've captured them in their very busy in all kinds of things: space, cyber, AI, and beyond. They're world-recognized experts, and they're going to help us explore, with this limited time we've got today, some of the various emerging questions that, frankly, are developing in many experts' minds today. So I'll just say, as I introduce them, welcome, Sam, and welcome, Neil.
Harry, really looking forward to the conversation.
Great. Great to have you here.
Thank you, Harry, and I am as well. I'm Sam Visner. I wear a couple of hats. My principal hat is as a tech fellow at the Aerospace Corporation, which is the federally funded research and development center that is focused on support to our nation's space enterprise, engineering, research, development, prototyping new technologies. I also serve as the vice chair of the board of directors of the Space Information Sharing and Analysis Center, which is the principal information sharing conduit between government and the private sector regarding cybersecurity threats, risks, mitigations to our growing national space enterprise. So thank you again, Harry, for inviting me.
It's great to have you here.
And I'm Neil Serebryany. I'm the CEO and founder of a company called CalypsoAI. At CalypsoAI, for the last 4 years, we've been leaders in the field of securing both the underlying data as well as the machine learning models that are powering kind of our current revolution that we're seeing with generative AI, and we're seeing within the kind of broader field of large language models. We do quite a bit of work in the public sector, helping support many, really important national security customers in their application and use of machine learning, as well as on the private sector side of the house, really helping to enable use of machine learning models while providing guardrails along the way. Very excited about the conversation and looking forward to all of the kind of intersections here.
Great. Well, it's wonderful, as I said, having these two gentlemen here. And let me just add something about Sam. I've known Sam now for many, many years in many, many dimensions. Most of us knew him for his long duration at MITRE Corporation, and he actually was the director of the National Cybersecurity federally funded Research and Development Center. We often refer to that as FFRDC, and that was sponsored by the National Institute of Science and Technology. So that's just one other piece. Sam also served as a general manager of several cybersecurity businesses. He teaches at Georgetown University today, and he also served as the chief of signals intelligence, SIGINT, back at the National Cybersecurity Agency. And let me just say a little bit about Neil too. He's a new friend. We've just met, but I'm looking forward to a rich future with him. But from what Neil said, I was also impressed that according to Gartner and Forrester, CalypsoAI, which he's the leader of and the founder of, they are known for developing and delivering AI security solutions. And according to them, they are the leader in that area. So I'm very excited about the two individuals we have today for conducting this rich discussion that we're going to have on these intersections. So I wanted to start off with a question, and Sam, I'll ask you to start. First off, what we're hearing an awful lot throughout the space and cybersecurity areas today is something referred to as cybersecurity in space. It's also being referred to as space cyber. So it seems to be a topic of really growing interest and concern. So Sam, I'll start with you. What are your thoughts about space cyber as it relates to protecting critical space infrastructure?
Well, Harry, thanks for giving me such a softball question to start. I appreciate that very much. A long time ago, which is to say, maybe 20 years ago, 30 years ago, we didn't really think so much about the convergence of cyberspace and space. Most space systems were standalone. They had their own command and control and telemetry systems. We thought they were fairly secure. Mostly they were. And very little of the nation's infrastructure depended on them. And they didn't depend on our global telecommunications and information technology infrastructure. Now that's changed. There are two meta dependencies that I think are very important to consider here. One is that just about every critical infrastructure you can think of, whether or not it's finance, energy, oil and gas, transportation, healthcare, agriculture, which is a big one, depend on space systems. Agriculture, for example, absolutely depends on space systems. We use space systems to navigate not just your truck to your supermarket, but also to get your combine, your harvester, to the square inch or square centimeter of the field that you want it to cultivate. We use communications to be able to monitor the soil conditions, as well as to communicate with all of these devices and all of the machinery on the farm. And we use remote sensing to be able to look at soil conditions and where to plant, as well as more global observations regarding weather. And there's been talk that if we lost our space systems today, we'd lose some 20% of our food system, of our food production in the United States tomorrow. I don't know that that's empirically true, but it sounds directionally correct. And oil and gas, to know where things are, to communicate with them, to be able to digitize the oil field, all of these infrastructures depend on space systems. But space systems now increasingly depend on the global information infrastructure. We're looking at not only ground stations, but ground station as a service, storage on orbit. We're looking at the dependence of space systems on a global information infrastructure to be able to support everything from additive manufacturing of new parts and launch vehicles, which we're now seeing, to be able to manage just the supply chain of things that are up there, to all of the complex systems, telemetry, mission systems, and all of the other systems that are on these space vehicles. And no longer are space vehicles isolated from the global information infrastructure. We're going to be seeing what we call the new hyperscalers. Today, we have companies like Google and Amazon and Microsoft and Alibaba, which are building huge data centers all over the world and the connectivity to support them. In future, those infrastructures will support smart cities with machine learning and artificial intelligence. And the overall network that connects all of this will be these new space-based 5G and beyond 5G networks. So the intersection of space and cyberspace and the need to secure both of them with solutions that work for both of them at the same time has now become an urgent priority for the country.
Well said, Sam. And with that groundwork, I'd like to turn it over to Neil now to add some thoughts on, your specialty area is artificial intelligence. How does it fit into this new world that we're calling and new requirement that we're calling space cyber?
Yeah, that's a really good question. I think it's incumbent on us to go one step back and talk about, why is AI intrinsically even interesting to us? And the reason for that is really simple. If we think about silicon and we compare silicon to kind of our biologic systems, we don't have any way of being able to constantly and perhaps on an exponential scale progress on the biologic system. We do on the silicon. We have the ability to create machines that are smarter and smarter and smarter and smarter over very, very long periods of time. This is also known, in other words, as the scaling hypothesis. Essentially, the idea that we'll be able to get to perhaps human-like intelligence, and this is a debated theory, but we'll be able to get to human-like intelligence at some point by just constantly increasing the amount of compute we have available over a sufficiently long enough period of time. The intersection between space and AI is very interesting, and there are a couple of points of intersection. One, the obvious point of intersection is, what percentage of our worldwide telecommunications are carried via space, and the percentage is very high. Then you have your more kind of space-specific concerns. So whether you have potentially artificial intelligence models running at the edge in space, and you have both an opportunity vector as well as a security vector there. Two, you have opportunities as well as risks and threats in the context of how we're receiving and sending signals to our space-based assets. And you have machine learning as an intrinsic part of that. And then three, going a little bit more holistically, you have a new generation of threats that's been developed on the basis of threats to your machine learning system, which are predominantly in the form of the data that underlies those machine learning systems, or in the way that you interact with those machine learning systems. But you also have all of your traditional cyber threats that are only enhanced through the advent of machine learning, and in particular, large language models, and which are only growing faster. And you're getting into this era of essentially machine on machine cyber warfare, which obviously has quite a bit of intersection with space.
Great. Thanks, Neil. Okay. I'm going to turn now to kind of more of a hardcore AI type capture here in question. Frankly, artificial intelligence is capturing the minds, perhaps literally in some cases, of almost everyone these days. And it has become one of the hottest topics throughout the world in every area that I can think of. So Neil, CalypsoAI, the firm you founded about 5 years ago, and lead today, is known among many as the leader in security for AI today. So what roles do you see today and perhaps envision for tomorrow for AI in protecting critical space infrastructure?
Yeah, that's a really phenomenal question. And what we're really getting down to is, what is the traditional stack we have from a cyber perspective? So your typical organization would have what's known as a security operations center, or a SOC. They would be running some sort of software that takes all of their signals together. So they would be running what's called a SIM. And then they would be running essentially endpoints. So whether it's an endpoint for all of the computer systems they have on their network, whether it's a bidirectional gateway for allowing network traffic into their network or not, or whether it's any number of other kind of cyber-specific tools and technologies that have come about in the last couple of decades. And there are a couple of kind of really big opportunities for AI there. One is to, let the human ask questions in natural language. So for example, if there is an alert of some sort, or there is an incident that someone is investigating, enabling them to be able to ask questions about that incident in human speech and detect patterns, and ultimately allowing the human to move to higher productivity, higher risk alerts, and letting AI take care of all of the noise that exists there today, and serving as that kind of interconnected layer between all of the cyber infrastructure that you have. And perhaps actually even working in the context of the larger kind of large language model or foundation model infrastructure that your organization has developed, where you're going to have a large number of sets of models across your organization. Some of them can be cyber-specific models and fit into the broader enterprise architecture that you have.
Neil, that's a great point. And I hadn't thought about it totally in the context that you just made. But I know, having worked in cybersecurity and space, large parts of my both military career and my civilian career, I know one of the things that we were always looking for were qualified individuals. And we have a national and global shortage on cybersecurity trained people. So you've just given us renewed ideas about how we can supplement that. And the space community is the same way. As space continues to grow in its intensity and applicability in so many areas that Sam just highlighted a few, this AI can really help in so many ways in meeting the demands that we can't meet with just individual by individual. So let me turn to Sam now. That question, and what are your thoughts, Sam, about AI in space?
Well, I think there are going to be several aspects of this. First, I think we are going to see, and Neil touched on it, and I think it's worth elaborating. We're going to see the use of AI in space essentially as an edge computing feature. I'll give you an example, two examples, and this audience, being the audience it is, will be able to develop to imagine more. Let's assume today that you are an emergency manager, God forbid, in an area that has been hit by an earthquake or a hurricane, or some other natural disaster, or a giant dinosaur, whatever it is. And you have a lot of decisions to make, and you don't really have a lot of time to make them. And it's one thing to get a picture on orbit that shows where the damage is, and maybe another picture on orbit that shows where a hospital might be. That's useful, but what does that really mean? Now, what you would really like to get would be a set of pictures on orbit, along with some AI generated courses of action that says, here is where we think of the most damage. And this is the kind of damage we think has been caused. And these are the estimate of the number of people who've been injured and the kinds of injuries they have. And here are the emergency resources and facilities that may be available. But these are the egress routes that have been blocked, and these are the ones that can be opened. And here is a recommended allocation of these people to these resources and these resources to these people using this route. And given the kind of information that is available on orbit, coupled with the use of AI, in this case, generative AI, to generate courses of action that an emergency manager or an emergency management team might consider, that's an area where AI can make a real contribution. And Harry, as a former warfighter, think about a commander on the battlefield, looking at the disposition of our forces, the disposition of an adversary's forces, their resources, our resources, the terrain, being able to make a recommendation or a set of recommendations, maybe several alternate recommendations about the courses of action that would be available. So I think that's going to be an issue. The second issue is the global information infrastructures and global smart infrastructures, smart cities, smart regions that are being enabled, that will be enabled increasingly by these global 5G satellite-based networks. They're going to be very difficult to detect malware and anomalous behavior. How do you determine what is anomalous behavior in a city of 20 million people with perhaps 1 billion IoT devices? Some coming on, some turning off, some being commissioned, some changing their status all the time. To be able to detect a signal of anomalous behavior that could reliably indicate a cybersecurity problem, an exploit or an attack, that's something AI could conceivably do. And it might be able to do it on orbit with the speed necessary to respond. The kind of security operations center that Neil discussed earlier, that may be a thing of the past. It's going to be too difficult to monitor these complex interconnected networks with millions, if not eventually hundreds of millions or even billions of devices. And for a SOC operator to look at a screen and say, well, you know, I think there's a problem, I better call somebody. The speed with which that happens is far too slow. It's simply not going to be feasible in future. I think AI is going to play a strong role as we become more adept at using it.
You know, Sam, those are great points. And I will, you brought me back to a couple different situations in my military career where AI could have done exactly those kinds of things that you just mentioned. The first couple examples that I had was when I was assigned to U.S. Central Command with an area of responsibility that was in the Middle East, throughout the Middle East, but with its headquarters at MacDill Air Force Base in Florida. And I can remember the shock we got when we heard that there had been a large truck bomb that had exploded at Khobar Towers in Kuwait. It was a shock to all of us. We had been in the Middle East a lot, but we just happened to be back at home base with the 4-star and our traveling team. And so the first things we saw were, thank God, we got imagery, overhead imagery, to give us an idea of what we were dealing with here, because you're talking about Kuwait and Khobar Towers and massive destruction and loss of life. And so we were clamoring there in Tampa, Florida, to try and figure out what all was going on and to assess battle damage assessment. So what you've just talked about is that. I can remember also that it was a very active period of time in Central Command where we were launching Tomahawk missiles at enemy forces over there, and to have battle damage assessment on Tomahawk missile strikes, you know, from a distance, you know, would be very important. And your point was great. Probably my biggest example, and it wasn't at distances that far, but was during the 9/11 when we had terrorist attacks that attacked our Pentagon. I never thought I'd see our Pentagon burning for 3.5 days. I happened to be the district director at that time, so communications there was my responsibility to keep running or to repair. Also, I happened to be the National Cybersecurity or the National Communications System manager. So I managed all of the communications, my staff, for putting New York City back together. And that was 5.5 million voice and data circuits that were down. Now, we were in closer proximity to be able to take a look at battle damage assessment and all that, but I think about even the compounding and the complementary nature of what AI could do, even in that closer proximity, in addition to what it could do at distances halfway across the earth from where you are. So that was those are great points. Neil, do you have any thoughts on that?
Yeah, a couple of thoughts there. So number one, data integration is a challenge as old as time. It continues to remain a challenge today for enterprises, but also, of course, the DoD. Just the number of systems that you have at any point in time. Obviously, one of the benefits, especially as we start to tune out the number of hallucinations in the context of large language models, is the ability to build more and more connectors between our systems that aren't necessarily talking to each other right now, as just one kind of direct benefit for what you were talking about there. The other side of the house here, and what we probably can't let ourselves forget, is this is great. There are lots of fantastic applications for large language models, for foundation models, for AI more broadly. There's also a whole new generation of cyber risk, AI specific risk that's being developed, and the ability to either directly attack or fool the AI systems as well. And that's really where kind of your cutting edge software, like some of the software that we create and others create, kind of comes in to help you bridge that gap between, the benefits of AI, but also the kind of added risk or the new attack surface that's being created as well.
Great.
May I add a point to that?
Sure.
One area that I don't think is getting nearly enough attention is the adversarial use of AI. And we talk about it, but I don't think it's getting really the detailed attention, Harry, Neil, that it deserves. I mean, to be able to look at a complex network and use AI, some kind of generative AI, to say, based on what I see of this network, here are where I think the vulnerabilities are. And let me craft some malware on the fly using AI to be able to exploit that, to be able to exploit those vulnerabilities. I think to be able to model an adversary's network, to be able to model and understand its vulnerabilities, to be able to understand how it's defended, to be able to detect a vulnerability, to be able to detect or create a point of ingress, and to create on the fly the cyber weapon necessary to exploit that weakness. I think that's something AI ought to be able to do, is likely to be able to do. And we ought to be on the lookout for attempts by adversaries to do so, because I think it's inevitable that this is going to happen.
Absolutely, Sam, and that's probably the subject of a whole other area, is the threat, that we would see from AI, because we're talking about lots of great opportunities to help, but also we're going to have, like anything good, somebody's going to turn it into some sort of a weapon or a threat against you, and that's a whole other area. And let me, again, we talk about cyber and AI, and that we really must consider them as integral parts of protecting the many aspects of our chosen subject today, which is space as a critical infrastructure. But let's explore also quickly the specific area of supply chain management. And specifically space supply chains.
Are we talking about the data supply chain or the actual infrastructure supply chain?
I think it's both hardware and software.
Okay.
And so I'll tee you up, Sam. I know I know you work in the supply chain, critical aspects of space. So then Neil will get your comments.
In fact, I was just communicating with the supply chain risk management group this morning before I came here of the space ISAC. Wow. Well, if you go back some years, and this is with a little hyperbole, but if you were NASA or the Air Force some years ago, you'd say, where'd that part come from? I want to visit the factory. All right, factory, where did you get that bolt? I want to see what company made that bolt. All right, company that made the bolt, I'd like to visit the place where the steel was poured. All right, steel mill, I'd like to go to the mine where you mine the vein of iron ore. You could have a great deal of visibility into the supply chain. And whether or not that case is true, That level of visibility is something that we used to have. We don't have that necessarily anymore, as we put up literally tens of thousands of new satellites, right? 3,300 from Blue Origin, 12,000 from SpaceX, several hundred from OneWeb, over 200 from Maxar, Planet Lab are putting up constellations, Synectic, KSAT, and others. We are seeing a commoditization of the global supply chain that goes into both the hardware and the software associated with space systems. Can we do a better job of understanding, using information technology, the provenance of all of this hardware and software? And conversely, if the IT that is used to control that supply chain is compromised, how do we know that the part we're getting is the part that we're supposed to be getting and from the place where we're supposed to get it? Yesterday, I attended a conference on digital forensics, and I had a very, very interesting meeting with somebody who talked about additive manufacturing, which we're going to use both to make rockets. Relativity Labs has demonstrated they can do that. And we're going to do manufacturing on orbit. Instead of bringing all our supplies up, we will mine space for raw materials and use 3D printing to print the stuff we need for colonization and exploration and other purposes. The software that controls that fabrication is very subtle. Any change in the density or speed by which the filament is laid down to make a part, and that part could be visually perfect and yet fail some calculated percentage of the time. So that is a combination of both the hardware and software elements of the supply chain for space systems that need to be secured.
Neil?
Yeah, it's a really kind of terrific point that you have there, just around kind of the integrity of the supply chain. You're also getting into kind of the broader factory conversation around just-in-time manufacturing, Kaizen, and some of the kind of globalization concepts that we've developed over the last 50 odd years or so. My domain would be much more in the kind of digital supply chain side of the house. So, let's think about an AI model just as a kind of example here. So if you have a large language model, you have a foundation model. That model has been trained on a staggeringly large part of the openly accessible internet. It has cyber vulnerabilities. It has AI vulnerabilities. It's intrinsically built with a large set of vulnerabilities on the basis of how large it is and what percentage of the internet it contains. Within the context of kind of your more traditional applications of CNNs or SVNs or other types of machine learning, you're using open source libraries for much of what you're doing. You don't necessarily know what the lineage of those open source libraries are, or if there is vulnerabilities, other than trusting the fact that because it's open source, someone else has reviewed it and looked at it. You're then using a data set. That data set may be a data set that you control and have the lineage on, or it may be a data set that you don't control or you don't have the lineage on. And so as you're going through that process of actually building your machine learning model, you're doing so in a way where security isn't necessarily at the heart of the process. And frequently, the folks that are actually building those models aren't necessarily the same folks that are thinking about how to secure the model or thinking about it from kind of a risk-based framework perspective. And so you also have the kind of internal need to collaborate with both the folks with the data science background as well as the folks with the security background.
Wow, we're getting at a whole lot of huge subjects here. We're scratching surface on a number of different areas, but I knew that's what was going to happen because that's the universe, if you will, that we work in with those fourth and fifth operational domains. But each of you have touched on this a little bit. There seems to be a compelling need now for a repository of systematically collected and analyzed data on cyber threat activity and other areas of cybersecurity, resiliency, and even recovery. So protecting our space critical infrastructure, which is why we're here talking today, requires data that really is accurate, timely, and pertinent to everything from making policy to making operational decisions on a daily basis. But here's the question. The Cyberspace Solarian Commission recommends creating a Federal Bureau of Statistics to support a broad range of needs, along with public and private sector users. So what are your thoughts on establishing such a federal bureau? Neil, I'll go to you first.
Oh man, every time someone talks to me about statistics, I think about Kahneman and Tversky, and the first couple of pages of their book where they talk about asking statisticians intuitive questions about statistics. But to kind of answer the question directly, I certainly think that there is a place for the public-private kind of partnership in the context of reporting and understanding cyber incidents. The closest we probably have today would be VirusTotal, which is an openly available service that's currently run by Google, as well as from a kind of a framework perspective, it might be one of MITRE's frameworks in the form of the MITRE ATT&CK framework or now the MITRE Atlas framework. But I could certainly see the kind of compelling need for stitching it together. Sam?
Yeah, I think that's right. Harry, I do agree very much with the Solarium Commission report, and the Armed Forces Communications Electronics Association has issued its own paper, which echoes that recommendation. I think one of the problems that we face is that good empirical data about cyber problems is lacking. And as we become more dependent in our infrastructures on information technology and cyberspace, I mean, we don't depend on cyberspace, Harry. We exist. We reside in cyberspace. That's where we reside now. Our electrical power grid doesn't depend on it. Our transportation system doesn't depend on it. They reside within cyberspace. There is a bill in Congress that would also recommend the development of a cybersecurity of a space systems cybersecurity clearinghouse. I'm hoping that bill will pass. I'd like to see the Space ISAC be given that role. And while I'm at it, let me again foot stomp the need for us to make the long overdue decision to declare our space systems a critical infrastructure sector. They have their own unique infrastructure, unique missions. Not only does everything depend on them, but there are things that they do that no one else does, like remote sensing and GPS, GNSS, navigation and space manufacturing, space exploration, space travel, space colonization. Increasingly, those are going to be important to our national and economic security. So I'm hoping that declaration will be made. And as it's made, the need to be able to accrue and analyze empirically useful data is going to become vital to the success of the mission.
Absolutely. Well, Sam, you've reminded me that maybe it's an appropriate time for me just to foot stomp the fact that we have a space ISAC that just started and stood up in 2019. Our first 2 years of running that and looking for members was during the pandemic years, so it wasn't the best time to be socializing something. But our space ISAC now that is operated, as I mentioned earlier, by the National Cybersecurity Center in Colorado Springs, we now have over 70 members of the space ISAC. And Sam, you're the vice chair of the space ISAC. I think you can see, audience, the brilliance that we have that's running space ISAC. So let me just we have about 2 minutes left, but Sam, you mentioned Congress, and in fact, there's a new report that came out by the U.S. Government Accountability Office, GAO, and they sent that to the Senate Armed Services Committee. And that report found that DoD needs to issue department-wide AI acquisition guidance. And interestingly, I heard just on the news last night that today the U.S. Senate is holding their first classified briefings involving AI. So that's happening not too far from us where we are here in Washington, D.C. now. But there's a number of areas that they might be exploring at that hearing and others. But what are your thoughts on how we should be, how the DoD perhaps should be considering a department-wide AI acquisition strategy?
I think it's a very good recommendation that GAO has made. I have a lot of respect for the people who work on these reports at GAO, and I think it's something that probably is overdue. Now, having said that, a lot of systems are built, based on very specific requirements, very specific specifications, and very specific use cases, and these things are built in silos. But now, as we move to unified command and control systems, things like JADC2, where we're trying to be able to unify command, control, communications, intelligence through all of our services, and something that we've demonstrated is useful, looking at the conflict, the war in Ukraine, I think it's time for that kind of guidance. I have another reason for saying this, by the way, and that is the Department of Defense is large and people sometimes think of it as unwieldy, but it can actually be pretty darned effective. It does things no one else can do. And if it does this, it can set an example and standard that other parts of the federal government can emulate. And therefore, I'd support it.
Okay, great. Neil, closing comment.
Thanks so much, everyone, for having us. Really enjoyed the conversation with both of you, and looking forward to the next one.
Great.
Thank you.
Well, I think we teed up a lot of subjects today. We only scratched the surface, as I mentioned earlier, but I think this is going to be an opportunity for us to continue in areas with the America's Future series at exploring some of these other broad areas that are involved with space, cyber, and now the area that we're getting very much involved with in everything, artificial intelligence. But I want to thank my two friends, Sam and Neil, for being here with me today. I'm honored in your presence and your brilliance. But thank you very much for listening in today.